Okay, so we have done regression last unit with when we had the half-life and all that, and then when we had the graphs. So what we're talking about today is how to know which equation fits the data best. So we did exponential because we knew that they were all exponential. So today we aren't sure with the word problems which one is going to fit best. So I'm going to show you how to figure that out. So the first thing that you want to do is in your calculator. So everybody in your calculator, hit second 0. So second 0 takes you to a catalog, and this is everything that your calculator has on it, everything that your calculator can do. So what we want to do is turn the diagnostic on. So you can scroll all the way down till you get to diagnostic, or you can click on x to the negative 1, which is right beside the sign, and then that skips you down to D. And then you can just scroll, and you want diagnostic on. Okay. So everybody needs to do this, or you won't get any answers today. So then you hit enter, and it should say done. Okay, so again, to get there, I hit second 0, x to the negative 1 took me down to D, and then we go down to diagnostic on, and then enter. Okay, it may not get there. Alrighty. So now let's find some regression. So let's look at this first graph. What kind of graph is this first graph? Anybody know? What makes a U shape? A quadratic, yeah. So this first one is a quadratic. Good. So we've done exponential, we haven't done linear, but for exponential and linear, you only need 2 points to type it in and find the regression line. For quadratic, you need 3 points. Okay. So it gives us our first one here at 1, 3. So there's one of our points. And then the other one I wrote on top of it, but it's our y-intercept over here, which is at 0, 5. And then one thing, hopefully, that you remember about quadratics is that they are symmetric. They have this axis of symmetry. So if I have a point at 0, 5, if I come across here, I'll have a point here, which is at 2, 5. Okay. So you need 3 points for a quadratic. Then we type them in just like how we did with the exponential. So we go to stat, hit enter, clear all this out. L1 are our x's, 0, 1, and 2. And L2 are our y's, 5, 3, and 5. Now, we go back to stat over to calc, and since this is quadratic, we want to use quad reg, which is number 5. We're not wanting to find anything except the thing, so we don't have to worry about storing it. Enter. So now, hopefully, when you type this in, you got something extra, which is this r squared. Equals 1. So the r squared tells you how close to, well, how well your equation matches your data points. And you want r squared to be as close to 1 as possible. So like in this one, r squared is 1, so that means our equation matches our points perfectly. Okay? So then if we write this equation, we have 2x squared minus 4x plus 5. So again, r squared tells you how closely your equation matches your data points, how well it fits those points. And you want it to be close to 1, as close to 1 as it can be. Question on that. Alright, let's skip down here to number 7. So number 7, we want to find a linear model and an exponential model for the data, and we want to decide which one is the best fit and why. So, first thing we have to do is type in this table. So we go to stat, we hit enter, clear out what we got in there, and type in our new table. Now the good thing about these is that you only have to type in your table one time, and then you can find all of the models from your one table. So we want a linear and an exponential. So let's do linear first. So we go to stat, over to calc, linear is number 4, enter, 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 and there it is. So we've got 23.55x minus 16.11, and this r squared is 0.82998. So let's write that one. So linear, we've got 23.55x minus 16.11 equals y. And then this r squared is 0.8299. Any question on that? Anybody not get that? Anybody's r squared not pop up? Anything? Okay, so then we also want to find an exponential model. So we can go back to stat, over to calc. Exponential is what we were doing last unit, so we want to use number 0. Enter, 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 enter. And so we get this. So 4.97 times 2 to the x, and then our r squared is 0.9999, etc. So our exponential model is 4.97, 2.001 to the x, and our r squared is 0.999. So which one matches the data better? Which r squared is closer to 1? Exponential, yeah. So exponential. Good. And again, you want that r squared to equal 1. So this one is pretty close to what it should be. So now we want to predict. You can solve them by hand like what we did last unit, or you can store them into y equals. So let's do that. So the only one I care about is exponential because it was the better model. So I'm going to go back to stat, over to calc, and 0. Okay. Then where it says store regression equation. So again, I went stat, I went calc, I went 0. Store regression equation. You hit alpha, which is your green button, trace, which is right beside graph, and y1. Okay, so again, alpha, your green button, trace, Y1. And then enter, enter. Okay. So it still pops up like it did before, but if we go to Y equals, there it is. Okay, so then part C, we want to know predict Y when X equals 10. So I want to go to my table and I want to see where X is 10. I don't want to scroll. So if yours is at something weird, you can hit second window and do your table start as 10. And then when you go back to your table, it takes you to 10. So at 10, we've got 5,169.31. The exponential, yeah, because it was the better fit. Questions on that? Okay, so then for part D, we want to predict X when Y is 30. Well, if I look at my table, I've got 2.1 is at 21.4. 2.8 is at 34.8. So I know it's happening somewhere in between there. 2.1 and 2.8. So if you look at your calculators, your tables are probably just going up by ones. So you're like, well, how do I know? Like all I have is 2 and 3. You can change that. So if you hit second window, this little triangle table, that is what your table is going up by each time. So I could make it go up by 0.1. And so now instead of going up by ones, if I go to my table, now I see 2.1, 2.2, 2.3. And so then I can see, well, at about 2.6, I'm at pretty much 30. Again, not exact, but pretty close. So I'm going to say 2.6. Okay. And again, to change your table, you hit second window. The table start, that's what you want to see. So let's say you wanted to know when X was 500. You would just type in 500 or whatever you're looking for. And then this little triangle table, that's what it's going up by each time. That's your interval. So if you make it 0.1, don't change your independent and dependent, but you can change those two things. Any questions on this one? Alright, let's do one more. Let's look at number 10. So down here, number 10, we've got the number of insured commercial banks, which is our Y in thousands, in the United States for the years 1987 to 1996 are shown in the table. Let X represent the number of years since 1987. So it's telling me these years are the years since 1987. So 1987 is our starting year. So that's our year 0. Remember, you don't want to type the actual years in. You want years since 1987. So how many years since 1987 is 1988? 1 year. How about 1989? 2. And then 3, 4, 5, etc. Okay. So those 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's what we're going to type in the calculator, okay? Not the actual years. So let's do that. So we want to use a graphing calculator to find linear, quadratic. We're not going to do power, we want to do exponential functions for the data, and then let's compare our r-squareds and determine which one fits the data best. So we want to find a linear, a quadratic, and an exponential. And then part B with each function. So we want to predict using each function. So what I'm going to do, instead of having to do them 3 times and then store them 3 times, we're going to store them all as something different. So I'll show you how to do that. So first let's do linear. So we go to stat, we go to calc, linear is number 4. Enter, enter, enter. So I'm going to store my linear as y1. So again we go alpha, trace, y1. And then enter, enter. So there we go. So we have negative 0.459x plus 13.6773, and the r-squared is 0.9981. So that's a pretty good r-squared. Put y equals. Yeah, so you type them all in, and then we want linear first. So we go stat, calc, linear is number 4. Enter, 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 and then we're going to store it as y1. So when you get down to the store reg, you hit alpha, which is your green button, trace, which is right beside graph, and y1. Enter, enter. Make sure you go back to your table. Make sure you didn't skip one, like you're off. They both have to end at the same. Okay. All right, let's do quadratic. So we go stat, calc, quad reg. So this one we're going to store as y2. So we go alpha, trace, y2 instead of y1. Did you get it? So again, alpha, trace, y2. Enter, enter. Okay, so there's our quadratic. So this one we've got y equals negative 0.004 x squared minus 0.422x plus 13.628, and this r squared is 0.9986. So that one has an even better r squared. Any question on that? Anybody not get that? Anything? Okay. So now let's do exponential. So we'll go stat, calc, 0. Enter, enter, enter. And then to store, we hit alpha, trace, and this one we're going to go y3. Enter, enter. So we get y equals 13.806 times 0.961 to the x, and this one has an r squared of 0.9934. So which one fits the data best? Good, quadratic. So linear and quadratic are super close, but that 6 is of course bigger than that 1, so it's closer to 1. So quadratic. Good. So then in part B, we want to know with each function, predict the average number of insured commercial banks in 2005. So if I'm starting in 1987, how many years later is 2005? Anybody? 18. Good. So I'm looking at 18 as my x value. So if we go to y equals, all three of our equations are there. So there's our linear, there's our quadratic, there's our exponential. Okay? So if I'm going to my table, so second graph, I'm looking at 18. Well, I'm at 2, so I'm going to hit second window, and I'm going to go to 18. And then I'm going to go again second graph. And so y1, that was our linear. So our linear model would predict 5.4. Okay. Y2 was our quadratic, so it would predict 4.7. And then y3 was our exponential, so if you click over, it takes you to y3, and it would predict 6.7. And then it says determine which function gives the most realistic prediction. Well, we said that our quadratic fits the model the best, so based off of this information, we would say the quadratic. Now, we don't know that for sure, because we would have to know the real number, but based off of our data, that's what we can assume. Any questions? Okay. Alright, let's write the steps. So if you need to know the steps, we'll write them on the back. Okay. So, of course, the first thing you do is enter your table. Into Stat Edit. Okay. Then you go Stat Calc. And then you pick whichever one that you want to use. So number 4 is linear. Number 5 is quadratic. And number 0 is exponential. Then when you want to store it, you go to where it says, let's say to store. You go to where it says store reg eq. So store regression equation. And then you click alpha, which is your green button. Trace, and then you pick, do you want it in Y1, Y2, Y3, etc. So you just pick whichever one you want to plug it into. And then you just hit enter, enter. Okay, so that's how you store it. Questions?